Okay, sorry, I got interrupted with a phone call, and so my video stopped. So to keep going on lesson 5, simplifying evaluating expressions, you're going to complete the rest of these as practice and just combine these and then evaluate them if you can. So 5x plus 6x, you're just combining those. They're both positive, so you have 11x. And then you take a look at this one. I can only combine these two. I can't combine this -3 with it. So 9a plus 4a is 13a minus 3, okay? And then down here, you can actually evaluate the expressions by plugging in the numbers that the variables are worth. So 5k, when k equals -3, is going to be 5 times -3, which equals -15. And then you can complete these, and we'll go over them in your Zoom. They're all pretty similar. It looks like we're just simplifying these and use number properties to place like terms next to one another. If you need another sheet of paper to do it like I did it on this, you absolutely should do that. And then these, you're expanding the expression just by using the distributive property and combining like terms. And then you've got this fun word problem down here. All right, the next lesson we're gonna work on is adding and subtracting algebraic expressions. So similar, but just a little bit further. We're gonna take it just a little bit further. All right, sometimes you may need to add or subtract algebraic expressions. When doing so, remember that you can only add and subtract like terms. You know that subtracting a rational number is the same as adding its opposite. So we talked a little bit about that. So like 5 minus 8 equals -3, and that's the same thing as adding its opposite. Like that. Number properties such as the commutative property and the associative property can help you add or subtract algebraic expressions. The distributive property can help you expand an algebraic expression or factor them. So let's take a look at this one. We've got the sum of 2x plus 3 minus x plus 4. Write the problem as an addition problem. So we flipped this one around. Or they flipped this one around. So they distributed this multiplication or this subtraction sign to the x and to the positive 4. So you see that this equals -1 times x, because you can assume that there's like a 1 in front of it because 1 times anything is itself. So it's just like -1 times x plus 4. So now I can multiply this -1 times the x and the -1 times the 4. So now I have -x plus -4. So then I can bring this down, bring the original one down, 2x plus 3 plus -x plus -4. So now I can combine these, -x plus -x plus 3 plus -4. So then my final answer is x minus 1. So let's take a look at, without all of the words, how you can do that. Minus x plus 4. All right, I want to make sure I do it the same way they did it. All right, so we're going to keep this one the same, so 2x plus 3, and then I'm going to do the distributive property here. So then I have -x plus -4, okay? And then I can also I can put a plus sign right here and say that this is -x because you're subtracting is the same thing as adding its opposite. Now I have all these beautiful addition signs to help me. So now I can combine those terms, this one and this one. So 2x minus, and when there's no number here, you can assume it's just 1x, right? So 2x minus 1x is 1x, and then positive 3 plus -1 is plus -1, right? And then this can be simplified even further because you know 1x is just x, and then plus a negative is just minus. So your final equation is just x minus 1. Kind of cool. All right, the term difference has many meanings. What does the term difference mean in mathematics? It means subtract or add its opposite. All right, let's keep going. An equilateral triangle has 3 sides. Oh, okay. Each measures 2n plus 3 feet. What is the perimeter of its triangle? So, for example, if you have this equilateral triangle, obviously they all equal each other, and the length of each one, oh goodness, the length of each one is 2n plus 3. 2n plus 3, 2n plus 3. So to simplify this equation, you're going to add all 3 sides together, right? Use the number properties to reorder and group the like terms. So 3n plus 3 plus 3n plus 3 plus 3n plus 3 equals, and so we're just going to like group them all together. 2n plus 2n plus 2n plus 3 plus 3 plus 3, 2n plus 2n plus 2n grouped. 3 plus 3 plus 3 is, what's 2 plus 2 plus 2 is 6n plus 9. Okay, so the perimeter of the equilateral triangle is 6n plus 9. Now, an easier way of do that is the distributive property, right? So if you've got 2n plus 3 and you're taking it 3 times, you can do this. So then you just use that distributive property, and that equals 6n plus 9. So that's another way of doing that. But what I do like what they did here, where they grouped all of the n's together and then all of the constants together, or just the numbers together, and then they did that because if you've ever done like squaring a binomial or squaring a trinomial, that's helpful to group them all together so you can combine them. All right, find the sum of 3 times the sum of x and 6 plus the sum of 3 and 9y. Then factor the sum. Explain the first part of the expression. So we've got 3 times x plus 6 is the same thing as saying 3 times x plus 3 times 6, right? Using that distributive property. So that's really 3x plus 18. So 3x plus 6 is plus 3 plus 9y is 3x plus 18 plus 9y. Use the number properties to group the like terms. So we're going to group 3x plus 18 plus 3 plus y. That's the same thing as saying, I'm just going to flip these numbers around, or group these numbers together. 18, these are the constants right here, or the numbers. And so that would be 21. So, and then it says factor, factor your answer. So even if I were to write, or I can keep it like that, it's no big deal. So basically what you're doing is all of these numbers right here have a number in common, have a factor in common. They have 3 is their greatest common factor. So to simplify this equation, or what they call factor it, is you can take that 3 out of each one of those terms. Okay, so if I take the 3 out of each one of those terms, I can put the 3 on this side of the this expression, or on this side of the parentheses. So 3 divided by 3 is 1, so I have 1x. And then 21 divided by 3 is 7. And then 9 divided by 3y, or 9 divided by 3 is 3y. So my factored form of the sum is 3 times x plus 7 plus 3y. So basically what you did here is you divide each one of these by 3. And by dividing them by 3, you're pulling that 3 out. So like if then you were to take this and distribute it, you'd end up with this. So for example, if you have, what do you have? 3x plus 7 plus 3y. Okay, so if you have this, is what we ended up with, and then you take that distributive property and push that 3 through, you have 3x plus 21 plus 9y. So those are equivalent expressions. So by factoring it is what it's called when you pull the 3 out, you're simplifying the equation. And you can only do that is if your numbers all have a factor in common. All right, let's keep going. How can you rewrite a subtraction problem such as x plus 1 minus 3 plus, or x plus 3 as an addition problem? Well, the way I can do that is I can push this negative through and change it to an addition problem. So this would be x plus 1, and then I'm gonna change that addition or this subtraction to an addition, but add the opposite. So this would be negative x plus negative 3. Okay, so you have like positive, positive, negative, negative, and then all of your operation signs are positive. So you're just like pushing that negative through so it's easier to add. Like I talked about at the beginning when we were doing this, this stuff's tough. So if you can change them into addition problems by adding the opposite, it makes it easier. And how do you factor an algebraic expression? Find greatest common factor and divide. All right, so then for these, you're gonna find each sum by combining the factors. Some of them it's just you're simplifying the equation, so you're not gonna like come up with a final answer because there are variables in here and you don't know what the answer to the variables are. So for example, you can take these parentheses away because it is addition and subtraction. You don't necessarily need them. You can use your commutative property. So you're just combining the terms. So 1x plus 1x is 2x. And then positive 6 minus 1 or plus a positive or plus a negative would be plus 5. Okay? So you're going to continue doing those with these. And then this is like find the difference. So with these, you're going to push that through. So this would be 9d plus negative d, and then plus negative 2. And I like to put parentheses around there so I can see those negatives. And so then 9d plus negative d, this is negative 1d, would be 8d, and then this plus a negative is just minus 2, like that. So continue with those, and then do the rest of these as for practice. Ooh, this one, sorry, my camera's all over the place. This one looks fun. So I'm excited to see what you come up with these. If you need any help with them, definitely Google chat me or email me, and I can just quickly, we can do a Zoom or a Google Meet, or I can just do a quick video for you to explain which one you may have had trouble with.